a world brought together through nuclear energy. In Jordan, life is made happier through light and energy. The first historic step towards Jordan's nuclear research and development is the Jordan Research and Training Reactor. The land of mystery, Jordan. Full of remnants of ancient history, awe-inspiring and captivating landscape of the Red Desert. Jordan is called the Diamond of the Middle East for its diverse culture and exotic beauty, by harmonizing religion and indigenous people with warm affection for guests and visitors. Jordan has a population of around 9.5 million. As the nation does not produce oil, Jordan imports over 90% of its energy from abroad. Since Jordan currently has facilities for 2,400 megawatts of power generation and expects a power demand of about 8,000 megawatts in 2030, the nation needs to increase its power facilities. Therefore, the Jordan Atomic Energy Commission plans to supply 30% of its total electricity generation through nuclear power by 2030 and is preparing to leap forward as energy exporting country. What are the research reactors and how are they different from the power reactors that generate electricity? When uranium undergoes nuclear fission in a power reactor, the heat from the nuclear fission is used to generate steam which spins turbines to produce electricity. However, research reactors are used for research and training, material testing, the production of radioisotopes, and analyzing the characteristics of substances using the neutrons emitted from nuclear fission. JRTR is a 5-megawatt research and training reactor for basic science research using neutrons, material irradiation, the production of radioisotopes for medical and industrial applications, and the production of semiconductors. Neutron imaging devices use highly penetrative neutrons to detect defects in materials such as fuel or aircraft components. This technology can be further utilized for the development of various components. Neutrons can play a big role in cancer treatment and new drug development. Also, they can also help in improving the quality of semiconductor silicon.
The Jordan Research and Training Reactor is considered the focal point and a major pillar for manpower development and capacity building for scientists, nuclear engineers, and researchers in Jordan. I see the Jordan Research and Training Reactor as a center of excellence involving the training and capacity building of engineers, not just in Jordan, but throughout the whole Middle East for decades to come.
The JRTR project was started by the Jordanian government in 2009 as a national project for the construction of a 5-megawatt research reactor for the purpose of research and training, to be built in the Jordan University of Science and Technology campus in the city of Irbid. The Keri Daewoo ENC Consortium of Korea won the bid among fierce competition. The winning of this bid was possible based on Keri's strong technical capability and rich experiences made in the process of the indigenous design, construction, and operation of Hanaro, a multi-purpose research reactor, and Daewoo ENC's various experiences in overseas projects. Nuclear energy has given a new dimension to life. Within half a century, Korea has grown from a nation without any nuclear knowledge to an advanced global nuclear energy exporter. Now, Korea is hoping to open a sustainable future together with Jordan by using its accumulated nuclear technologies and experience and developing viable future-oriented nuclear technology.
I'd like to congratulate everyone for the successful and timely completion of the JRTR project. Together, Korea and Jordan created an important precedent in building this research reactor. I hope it will become the center of Middle East in the areas of nuclear science and technology. I also hope that it will mark a significant milestone in the safe operation of research reactors around the world.
The construction of JRTR was completed within 6 years since its first groundbreaking in November 2010. It provided the momentum to start the full-fledged establishment of a nuclear history in Jordan. The KDC Consortium for JRTR completed the design, construction, and commissioning test for all systems. We also achieved the first criticality with the fuel loading into the reactor core in April this year, and successfully completed a reactor performance test for 6 months, thus obtaining the operation license.
JRTR 프로젝트는 국내 최초로 원자력 시스템을 일괄 수출해 결실을 맺은 프로젝트인 만큼 감회가 남다른 사업이었습니다. 2010년 계약을 시작으로 약 6년간 프로젝트를 수행하면서 많은 어려움도 있었지만 대우건설의 다양한 원자력 경험을 기반으로 슬기롭게 극복해 나갔습니다. 성공적인 준공을 위해 많은 도움을 주신 요르단 관계자와 한국원자력연구원에 감사의 말씀을 드립니다.
JRTR is an open tank-in-pool type research reactor for multi-purpose. Various proven and state-of-the-art technologies were applied during design and fabrication. Monte Carlo simulation was adopted for the reactor core design. Safety analysis proved that the reactor is safely shut down and maintained at all postulated accident events. The reactor assembly, fluid systems for core heat removal, and digital INC system were designed and fabricated with the international codes and standards. The fuel assembly was designed by Carey, and the quantity for 2 cores were manufactured by a proven supplier, CERCA, in France. Design and fabrication for all structures, systems, and components have been verified by international experts and nuclear regulators. The facilities for neutron activation analysis and radioisotope production were installed for utilization of the reactor from the beginning.
JRTR was built according to the IAEA guidelines and the regulations of Jordan. I would like to thank everyone for our dedication in overcoming a number of difficulties during this project. Our passion to achieve what we want have been the driving force behind our success.
The reactor assembly and all connected components were precisely installed using a laser tracker. The pool operation facilities have been verified for their reliable operability, easiness of reactor utilization, and maintainability with remote tools. The reactor performance were successfully satisfied through a step-by-step power increase test, including the safe shutdown of the reactor under all abnormal conditions.
We began commissioning tests with 19 JEC trainees for JRTR operation when they just came back from Korea last May. They enabled fuel loading and operate the reactor, and then we can successfully finish all of the commissioning tests.
Our JRTR is a full success story. It has a full passive system. We have worked with the KDC contractor in design review, construction, commissioning, and we have learned a lot from them. We have achieved the full 5 megawatt power successfully.
The Energy and Minerals Regulatory Commission is the National Nuclear Safety Regulatory Authority for Jordan. We realized that safety and the compliance with nuclear regulations is paramount. That's why we adopted the highest nuclear safety standards recommended by the IAEA, and we implemented them with the help of 2 internationally recognized safety expert houses, and we ensure the culture of safety at all times. That's why we believe that JRTR might be one of the best regulated nuclear projects of its kind.
Korea and Jordan have thoroughly prepared for the safe operation of JRTR over the past several years. JRTR safety has been certified by Jordan's Energy and Minerals Regulatory Commission, as well as by the Korea Institute of Nuclear Safety, including a peer review by international experts and the International Atomic Energy Agency. More than 35 Jordanian trainees have been trained and gained invaluable knowledge through their participation in the design, fabrication, on-site installation, and all commissioning tests necessary for the safe operation of JRTR. The safe operation of JRTR by JAEC personnel will be a model of nuclear research and reactor operation in the Middle East.
The JRTR is meant to be a cornerstone for radioisotope production, for education of engineers and scientists, and for research in the various disciplines of the nuclear sciences and reactor operations. Therefore, we have trained our manpower to conduct safe and efficient operations of the facility, and we have prepared the operational procedures that implement the best accumulated international experience in the field.
Jordan will improve public welfare by producing radioisotopes to be used for the diagnosis and treatment of cancer, and will pursue the goals of advancing the national science and technology using neutrons. Jordan will open the way for its evolution from the research reactor to power reactors through the establishment of infrastructures in nuclear technology and manpower.
The Jordan Research and Training Reactor, being a state-of-the-art nuclear research facility, will be the home of forefront nuclear research using neutrons. Very soon, we'll be cooperating with Kerry in the construction of 4 neutron beam ports, including a cold neutron scattering and a high-resolution powder diffractometer. This will be the focal point for training top nuclear scientists and engineers who will be running Jordan's nuclear power plant program for decades to come.
Most passionate, unremitting efforts, state-of-the-art technology in the world. The future of JRTR is to establish scientific and technical infrastructure in the nuclear field. JRTR will be the nuclear focal point in the Middle East.